The IEEE Sustainable Smart Lighting Conference. It used to be called the LS, the Light Sources Conference. And now, after a couple of years, we talk about many topics, not only the light sources, also the converters. But LEDs have progressed quite a bit. We have our guest, Gosha Perz. You have been working a lot on flicker, on whether the light quality is good from LEDs.
That's right. Yes.
Are they much better than they used to be many years ago?
Part of those are much better. Well, it depends a little bit, like where they're coming from and like a little bit who the manufacturers and stuff. So if you look at the market currently, and I don't want to point fingers, but if you look at the light sources which are just over there, so it's a nice example. You can go close to it, you can wave your hands, you will see the stroboscopic effect, right? So there is still a bunch of light sources on the market with a very poor quality, right? And I think this is a little bit of problem that we should still be aggressive, because like the current way of addressing the problem is to look into the new production things. So like let's look into the problem from the light sources which are about to be produced. Because you know that LEDs, they last for a very long time, right? So if there was a light sources which were like this one, for example, which were mounted like several years ago, nobody's replacing them, even though the light quality is very poor, right? So so there's a bunch of light sources which are there on the market of very poor light quality, but because they are still working very well, they are still there. Having said that, these things which are being new, like the new generations of light sources, they are most of them really good light quality. Yeah, that's right. Yes.
So we make a step back, because the problem with LEDs is that we have this 50 hertz mains.
Yes.
You converted that to a constant light level.
Yes.
And what I've seen you always doing is wave your hand to the light source.
That's right.
Explain us first why you're doing that.
We do wave to the light source, not to say hello to the light source, like maybe a little bit like introduce ourselves. Well, so the thing is, as you mentioned, right, in the mains we have 50 hertz. There's usually a rectifier, always a rectifier in the light source, so to have a DC. So that's being always converted to either 100 or 120 hertz, depending on the region where you are. And the thing with 100 or 120 hertz, it's not going to be visible as flicker. Like flicker being the direct perception of unsteadiness of light is visible between 1 and 80 hertz, right? 100 or 120, obviously, it's above 80 hertz. So the flicker is not a problem for most light sources.
It's not a problem, but on the other hand, what I heard is that in evolution, we were not the predator, but the prey animals, so we had to look in the corners of our eyes, and there we are very sensitive.
So again, the 100, 120 hertz is also not going to be seen in the periphery of our vision. Having said that, mains are usually not what they are supposed to be, right? So 100, 120 hertz, which is like from clear, undisturbed mains, it's not going to be a problem, but in a lot of cases, there is a lot of electronic equipment connected to the mains, and that can cause voltage fluctuations. So you might have different frequency components in the signal which is going into the light source, and that can cause flicker. And in a lot of cases, that's lower frequency. We had a few talks about that there's flicker is influenced by the instability of the power supply, right? We have AC power supply. They are not perfect in the signal that they are coming, and that can result indeed in a flicker. And that's usually in the range of like 30, 50 hertz, and that's indeed something that you see more in the periphery of your vision than in your central vision. That's right.
And that's exactly a topic that you have been researching. Yes. You have a PhD on that topic.
Here you go.
But light has improved since then. From what you hear right now, will that be resolved and only be the problem of the legacy lamps that we have?
Yeah, so the legacy lamps is a little bit different topic, right? So we should legacy lamp is very technology oriented, as in like there's if you have incandescent, it's an incandescent. So the difference between LEDs and legacy lamps is like LEDs comes in the waveform comes in many different shapes and size and forms, right? It depends largely on the driver. While the legacy sources, the light output is usually the same. So if you have magnetically ballasted fluorescent lights, they will always have this 120, 100 hertz component, and they will result in the stroboscopic effect. That is, when you wave your hands to this, you will see this discrete movement rather than continuous one, right? Having said that, we are supposed to phase out the legacy light sources, because of the energy consumptions and the things associated with that. I think we still need to conserve the energy, as the world is overpopulated a little bit. Let's face it, right? So the less energy we use, the better it is, right? So we should conserve energy for the sake of the planet, not maybe even for ourselves, but for the sake of the planet. So I think we should look more into the LEDs, and how to improve the light quality from the LEDs rather than in the we cannot really do much with the conventional. The electrically ballasted fluorescent light, high frequency. Perfect, no problem like this, no problem over there. So yes, I think the challenge is more into the LEDs rather than in the legacy sources. Having said that, again, the stuff which is there on the market currently, there's a bunch of poor quality LEDs, while the ones which is currently under production, they are usually good quality products.
So research is making progress, the good qualities.
It is.
LEDs
yes.
are making progress,
Yes.
and it's a matter of just picking on the innovation as it is being presented here at the IEEE Sustainable Smart Light.
That's right. Yes, a lot of good talks here in the. I've learned myself a lot, about the AC power supply and the influence of the flicker. A lot of good talks from the Swedish, community over there. So I'm happy to be here. Thank you very much. Yes.
Thank you, Gosha. Enjoy the conference.
Thank you.